Hello students, let us discuss the reactivity of group 17 elements towards hydrogen. All halogens react with hydrogen to give hydrogen halides. These can be represented by formula HX, where H is the hydrogen, X is the halogen. The reaction between the hydrogen and halogen can be written as H2 plus X2 give rise to twice HX. So it gives rise to hydrogen halides. These reactivity decreases down the group. That means fluorine shows reaction violently even in the dark condition, but chlorine react in the diffused sunlight, but bromine react with hydrogen only on the heating condition, while iodine react with hydrogen heating in the presence of platinum as a catalyst. It shows that the reactivity of hydrogen with halogen decreases down the group. In the general formula HX, if X is the fluorine, then the formula becomes HF, and if X is chlorine, then it becomes HCl, HBr, HI. Let us discuss some physical properties related to these compounds, like HF is liquid, but HCl, HBr and HI are gases. What is the reason for being HF is liquid? Because there is an intermolecular hydrogen bond between the fluorine of one HF with the hydrogen of other HF. Because fluorine is the most electronegative element, so it can form hydrogen bond with between the molecules. So because of the intermolecular hydrogen bond, the molecules are little bit closer, so it is liquid in nature. But in HCl, HBr and HI, which are gases, because there is no intermolecular hydrogen bond present in between these. So HF is liquid and others are gases. That is the reason is due to the most electronegative element fluorine, which can form intermolecular hydrogen bond. When we compare the bond length between the HF, HCl, HBr and HI, we know that from top to bottom the size is increasing. When the size is increasing, the bond length between them increases. So when the bond length increases, we can say that it is easy to break. So it is easy to break the bond between the hydrogen and iodide in compared to HF. So because of this property, we can discuss the properties like thermostability, reducing character, acidic strength and HX bond strength. That is, as the bond length increases, it is easy to break. Therefore, it is easy to break the bond between hydrogen and iodine. So we can say that the bond strength, it is weakest in the case of HI and the strength is greatest in the case of HF. So this can be explained on the basis of the size. Difference in the size, the bond length get differ, so the bond strength get differ. What about the acidic character? Because acidic character depends upon the property that which can gives proton easily. So when you compare this one, in this case the bond length is greater, so it is easy to break. So it gives H plus very easily. So which one will be the strongest acid here? HI will be the strongest acid. So this property is also we are comparing with the help of bond length. So then HBr, then HCl, HF. So we can say that HI is the strongest acid along the hydrogen halides of group 17 elements. HI is the strongest acid. When you compare the thermostability that also depend upon the bond length, because The bond length is greater, easy to break. Easy to break means that is thermally unstable. So which one will be the more stable? HF will be the more stable. So you can see that HF is the most stable, then HCl, then HBr, HI. So which is the most unstable? Which is the most unstable? That is actually the bond breaks very easily. That is unstable. So that is more acidic. So that is more acidic. So we can say that the acidic character, that is for hydrogen halides, it is increasing down the group. That means HF is the weakest acid, but HI is the strongest acid. So what is the reason you can give here why HI is the strongest acid than the others of the same members? Because the bond length, as the size of I is greater, so bond length is greater, easy to break, therefore easily give H plus. So better learns in point, that is greater the size, therefore bond length, greater the bond length, that is easy to break, and when it is easy to break, that is gives H plus easily. So these are the points which you need to remember for the acidic character. So it ultimately depends upon the size. So when you compare the melting point, boiling point, bond length, here the values are given. So you can say that the melting point is increasing down the group with the increase in the atomic number. Boiling point, also you can see the values here, and the bond length, which is clear from here, that is increasing top to bottom. So the bond dissociation enthalpy decreases. So the pKa value is given here for these acid. So it shows that the stronger acid will have a greater Ka value. Greater Ka value, stronger acid will have greater Ka value but smaller pKa value, because pK is minus log of Ka. So which one have the smaller value of pK, that will be the stronger acid. So here HI have the lesser value of pKa, therefore it have a greater acidic character. So that we have already discussed about the relation between Ka and pKa. So this is all about that is the reactivity of group 17 elements towards hydrogen. So we have compared the properties between the different compounds of hydrogen and halogen. So this is all about this video. Have a nice day.